Hi everyone, in this video we are going to discuss coal. So if you were to describe coal to a friend or a neighbor, you would probably say it looks like a big gross looking rock, like a dirty looking rock. But scientifically, I would like you to describe coal as a fossil fuel, specifically in the solid state. So let's look at the history of coal. We didn't always use it as our main source of energy. In fact, before the year 1800, we primarily used wood. And so we would go outside, chop down trees, break it up into little logs, throw it in the fireplace, and then burn it. We always have to do a combustion reaction. And the heat that is evolved from burning this wood, we would use to warm our bodies or warm our house or wherever it is that we were. But then from the year 1800 to around 1950, we started using coal. And the reason we switched to coal is actually very, very simple. The heat that is evolved from burning 1 gram of coal is significantly larger than the heat that is evolved from burning 1 gram of wood. And so it just makes more sense to burn coal. If you're going to burn 1 gram of coal or 1 gram of wood, you'd rather burn 1 gram of something that's going to make you feel warmer or warm your house faster. And so you definitely want to burn coal. So let's look at a couple things for current times, essentially, for coal. So right now in the year 2015, we have a couple different things I want to point out. So let's start by looking at this globally. So right now we use coal to meet about 30% of our world's energy needs. And so some countries use the coal a lot more than other countries. So for example, in places like Mongolia or South Africa, they use coal to meet about 93 to 95% of their total energy needs. So they are heavily dependent on their coal supply. But other places are not so much. So like in the US specifically, we actually own 28% of the world's coal reserves. So we are in control of the most coal out of any other country on this planet. So in second place would be Russia with about 18%, and then China follows them with about 12%. And so we primarily just use coal in this country to make electrical energy. So 92% of our coal supply is used to just convert that energy, remember, potential energy to kinetic energy to mechanical energy to electrical energy, which then goes out into the environment, out into the houses and schools and workplaces and everything. And so we primarily use our coal to generate electrical energy. So now, what is coal? What is it actually? I keep saying coal. Well, it's kind of difficult to come up with a molecular formula, but this is on average what we say coal is. So we say there are 135 carbons. We say there are 96 hydrogens, 9 oxygens, 1 nitrogen, and 1 sulfur. So on average, this is a molecular formula for coal. However, we know from earlier units that there are a number of different pollutants that actually exist on coal as well. So here are just a few of them. So let's start off with silicon. We have sodium, we have calcium, aluminum, we have nickel and copper and zinc. And now here are 3 just awful ones: arsenic, lead, mercury. So all of these pollutants are on coal. So they're always there. It's maybe a mixture of some. So maybe this chunk of coal has a lot more mercury, or this chunk of coal has a lot of copper. But overall, in a giant supply of coal, you have all of these pollutants just hanging out there ready to go up into our atmosphere upon combustion reaction. So let's do a little math problem here to kind of make sure we're all on the same page. Out of this formula right here, so we're just going to take the generic molecular formula for coal. What is the mass percent of carbon in coal? Go. All right, did you get an answer? Hopefully you did, but just in case you didn't, let's work through the problem together. So the first thing we had to do was establish the atomic mass of carbon, but then take into the fact that we have 135 of them. So on the very top of this, we would say we have 12.01 for the atomic mass of carbon, and then we're just going to multiply it times 135. That's going to give us our top part. So we want to know how much carbon we have out of the whole piece of coal. So on the bottom, we're just going to use the molar mass of coal. So if you calculated this out properly, you would have done 12.01 times 135 times plus 1.01 times 96 plus 16 times 9 plus 14 plus 32. So you have to do all of this in order to get the molar mass. And if you did that properly, you should get something like 1908.31 grams per mole. Okay, so this essentially turns out to 1621.35 all over 1908.31, and then they're both in units of grams per mole. And then for mass percent, we're asking you to do this in a percentage, so you have to multiply this by 100. And so if you do this out, so 1621 divided by 1908, multiply times 100, you end up with a mass percent of approximately 85%. When I calculated it out, I actually got 84.9, just so we know for real numbers. But about 85% carbon. So it has a huge, huge mass of carbon. So here is the question. Why do we use coal more than wood? So why is coal better than wood? And it essentially comes down to two things. The heat evolved from the coal is significantly larger than the wood. But why? Why does this happen? Coal has more carbon than wood. And so essentially what we figured out is that when you burn some substance, the more carbon it has, the more energy that is going to be evolved. But there's another little piece to that. Coal has less oxygen than wood. So we also found out that when you have a lot of oxygen inside of your component, whatever it is that you're burning, you end up creating less energy, or less heat is evolved. So there's two factors here. Coal has more carbon than wood, and it has less oxygen than wood. So those two factors help generate significantly more heat upon combustion. So let's look at some real numbers here. So let's look at our source of fuel, and then the heat evolved, or maybe energy. Let's say energy evolved. And then for energy, our unit's going to be in kilojoules per 1 gram of substance. So our first fuel is going to be wood. And so when we burn wood, we evolve anywhere between 10 and 14 kilojoules per 1 gram. So that's a decent amount of energy, but not a lot when you compare it to let's start with the worst form of coal, which is called peat. Worst form of coal has about 13 kilojoules evolved of heat per every 1 gram. And that is the worst because it has the lowest percentage of carbon. Okay, that makes sense. Now let's look at the very best type of coal, which is called anthracite. And now this one actually has numbers all the way up to 30.5 kilojoules per mole. So it's almost double when you look at wood. And so the reason anthracite is awesome is because it has the highest percentage of carbon, but there's also this one other little piece that just happens to be for this specific type of coal. It has the lowest percentage of sulfur. So it's actually not only giving us the most heat upon combustion, but it's also giving us the least amount of toxic pollutants. So it's a really good version of coal. The problem is our US supply of this is almost gone. Okay, we are almost out in the US, and so it's really, really sad. So this is what you need to get from this video. A, coal contains a lot of carbon and not very much oxygen. And because of that, we are able to burn it or do a combustion reaction and release all of that potential energy that is stored within the bonds of coal. Coal is an amazing fossil fuel, and it's in the solid phase. Take care of yourself, drink water.